Good afternoon, everybody, and welcome back to your second recorded lesson for Math 111 College Algebra. I realized in the last video that I sounded like a very exhausted first-time mom, which, side note, I am. But I'm going to try to sound a little more excited, a little peppier this time, so here goes nothing. We are still in our section on functions, and so we're starting out chunking information in very small sections so that we don't get too overwhelmed, especially with all the chaos and all the new things that are happening with our semester. So rest assured, we will pick up the pace later on in this semester. But for now, just make sure that you are staying on top of all of your coursework and not getting behind. Without further ado, here we go. At the top, I will remind you again, your learning targets are typically always at the top and in red or italicized. And last lesson, we determined whether relations between two variables were functions. We determined what the independent and dependent variables are. We're going to be talking about domain and range in a later lesson, but we at least discuss those terms, meaning domain involves x values and range involves y values. And then we very lightly introduced function notation last class, and we're going to continue with that piece of our learning target today and actually evaluating functions. So this last piece of our learning target is our focus and our goal for today's lesson. Your x is always used as your independent variable. Anytime we refer to the independent variable, you can automatically think of the x values. But you know, depending on how your function is written, we may write it with a different variable in mind. So you'll recall last class, at the very end, we talked about how something like this, since it is one-to-one, and a couple other reasons, we could rewrite it as f of x. The function of the variable x is how that would be pronounced. So y equals x plus 5 or f of x equals x plus 5, where the y value or the dependent value is the same thing as if I asked you, what is f of x? That's the same question as asking, what does y equal if ... And that's what we're going to be looking at today. If I give you a function written in function notation, can you evaluate it? Meaning, if I give you an x value, can you substitute that into the function and get a y value, or where the function exists at given that x value? Here are a couple different ways that we could write the same function. So for this first one, this is read as the function of x, or f of x, equals x squared minus 4x plus 7. So if I gave you an x value, you would plug it in everywhere that there was the variable x. Okay. That second one is f of t, or the function of variable t. And then the third one is written as the function in terms of s, or g of s. Those all are defining the same function, and the independent variable is simply a placeholder. So if this is the function of x, notice that x is holding a place in that function. This is the function of t. T is holding a place in this function. Okay? And so I could rewrite all three of these functions almost with like a blank system down here at the bottom. The function of some variable equals that variable squared minus 4 times that variable plus 7. And the reason why I've got it written out with this blank looking system is that when we evaluate functions, we're going to be putting a value in for that independent variable. And so everywhere that that independent variable is located, we would replace it with whatever number or whatever value is given. So instead of f of x, maybe I want to know, or maybe I will say, evaluate the function when x, evaluate the function when x is 2. So instead of having x written in all of these blanks, I would replace the x value or the x variable with a 2. The function when x equals 2 is 2 squared minus 4 times 2 plus 7. And then you would simplify that, and that would tell you what f of 2 is. Meaning, or written out in words, when x equals 2, the y value equals blank, or the function when x is 2 equals blank. And so that's all that we're going to really focus on for today's lesson. I will tell you that you're going to want lots of space to be able to work these out. Also, make sure you've got a calculator on hand, because things like this statement you can plug right into your calculator exactly how they are written. So we'll jump in immediately into some examples. We'll start out with a simple linear function, meaning the highest power on your x variable is a 1, which we don't even write half the time. That's a review for you guys of exponents. And this is our function, f of x equals 3 minus 2x. The function of x is 3 minus 2 times x. And I want to evaluate that function at f of negative 1, f of 0, and f of 2. And again, I'll keep saying it all throughout this lesson. F of negative 1, that is read as evaluate the function f when x equals negative 1, meaning everywhere that there's a variable x, I'm going to replace it with a negative 1. Okay? And so that's what you'll see in this first statement. For x equals negative 1, evaluate the function. So what is f of negative 1? Meaning, what does my function equal? What is the y value equal when the x value is negative 1? One of the things that you're going to see me doing is everywhere that there's a variable, I put parentheses around it, and that is so I can type it directly into my calculator exactly how it is written. That is not a requirement, but that is something that I strongly advise that you do so that you don't have any orders of operations issues, so you don't forget negative signs, so that you don't miss any exponents. Those are just some suggestions that I would make for you guys. So when I evaluate the function at negative 1, I'm really saying 3 minus 2 times negative 1. And when I simplify that, negative 2 times negative 1, double negatives, or negative times a negative is a positive value. So really what I'm working with is 3 plus 2, which equals 5. Okay? The second one that I've asked you to evaluate is evaluate the function when x equals 0, or tell me what f of 0 equals. So instead of 3 minus 2x, I'm doing 3 minus 2 parentheses. Okay, instead of the x, I'm going to do parentheses and plug in that x value of 0. And then based on your order of operations, or PEMDAS, you may have been taught, the first thing that I need to do based on order of operations is taking care of those parentheses values. So what is negative 2 times 0 in parentheses? That gives me 0. Okay? And 3 minus 0 is simply 3. Okay? Lastly, I want to evaluate the function at 2, meaning when x equals 2, what does y equal? Okay? So I'm going to substitute 2 into my variable x. So instead of 3 minus 2x, I'm going to do 3 minus 2 parentheses 2. Take care of your order of operations. Okay. 2 times 2 is 4, and 3 minus 4 gives me -1. Just to give you a visual of the importance or why you are learning about evaluating functions. Remember that functions can be graphed. We looked at several graphs last class with the vertical line test and even the horizontal line test as well. What does it mean when we're evaluating functions? Okay, here's what that means. When x equals -1, f of x was 5. So that's a coordinate point that we can then go graph for this function. And so this is a rough sketch, meaning it's not perfect or exact, but the visual is consistent with what the graph actually is. -1, 5 is somewhere up in here. Okay. For the second one, when the x value is 0, f of x is 3, or the y value is 3. So that would be somewhere around in here. Okay. And then lastly, when x is 2, f of x, or my y value, is -1. And so we're kind of way over here. You can kind of see through this graph, again, it's just a rough sketch, but even with that rough sketch, you can see how this makes a linear equation, which is exactly what we were given in 3 minus 2x. Okay? So some big takeaways. When you evaluate functions, you are substituting a value in for the independent variable. And then secondly, what you are getting from evaluating functions are really coordinate points that you can then graph to get a picture of that function. Okay, so that's all the new material that I really have for you. We'll take a look at the domain and range here in a second, and we'll kind of talk through that. But you should be able to A, evaluate the function, and then B, graph the function based on the coordinate points that you get from evaluating. Okay. Once we get a picture of the graph from part B, we'll be able to state the domain and range, which is the set of x values. Sorry about that, y'all. I have a bunch of dogs running around at the house. I don't remember the statement that I was saying, but I know that it was something to the extent of once we get a graph of the function, we will be able to state the domain and range, which is the set of x values and the set of y values that the graph has. So what I want you to do is I want you to pause this video and I want you to evaluate this function at these 4 different values. Okay, so pause the video and see what you can come up with, and then I will post these answers up in the video in just a few moments. Okay, here is evaluating the function when x is 2, so that first part, or f of 2. When x equals 2, what is f of 2 equal? It equals -1. And when I put that together, a coordinate point on this function, when the x value is 2, then the y value is -1. And so that will be one of our coordinate points that we can graph for part B. Here's your second one. Evaluate the function at x equals 0, or tell me what f of 0 equals. Okay. When I simplify this function, or simplify the evaluating of this function based on the order of operations, I get that f of 0 equals 1. And if I rewrite that as a coordinate point, then that will be 0, 1. So there is a second coordinate point that we will be able to graph for part B. I just want to remind you that you should be working through these on your own and then checking with my work in this video to see what you need to fix. And then if you still aren't sure about it, you still have questions, make a note of that in your notes and then contact me by email or the Remind app and let me know what you've got questions on, and if you want to ask those questions during office hours or if you want to try and just deal with them right then and there over the Remind app or email. Remember, you need to have specific questions when you contact me, not "I don't get it," because "I don't get it" is not a question. Make sure that you have specific questions in mind so that we can address them and get straight to the point and really solidify that content for you. Here's your third one. I just want to point out, because a lot of people tend to struggle with examples like this, -1 is what is being plugged into the equation, or what is being substituted in for the variable x. So -1 is completely squared. -1 all squared, or -1 times -1. -1, all of that squared, is just 1. But part of the original function is that there's a negative out front. And so a negative times this 1 will still give me a -1 for that first term. So I just want to clarify that order of operations. It gets a little nitpicky. It gets a little confusing for some students, so I just wanted to point that out to you. Other than that, you're simplifying just like you have been all the other ones, and we have a third coordinate point at -1, -1. Okay, this fourth one, you'll notice that I have not worked it out yet, and that's just because I want to walk through this one with you. This tends to be the most difficult one out of the 4. And the reason why is because you are not evaluating with just a whole number or a natural number. You're evaluating using an expression. Okay? An expression is when you've got one or more terms involving variables without an equal sign. So instead of having f of x, we are going to plug in x plus 1 everywhere that there was originally the variable x. So everywhere that we have just x up top, we're taking that out and replacing it with x plus 1. And so you will see at my first step in red, that's what your first step should look like. I took the x's out and I replaced them with that full group, or that full expression of x plus 1. So that means in this first part right here, x plus 1 is all squared, and then it is multiplied by a -1. Okay? And now, here's the first thing. We are not, I repeat, we are not going to distribute that squared. Okay? Nothing in the distributive property says you can distribute powers or you can distribute exponents. That is not allowed. You miss some crucial numerical values if you try to distribute an exponent. That is not allowed. Do not do that. So I'm going to actually get rid of those so that no one thinks that that is what you should be doing, because absolutely you should not ever, ever, ever distribute exponents. But particularly in this situation when you have an expression that is being raised to a power. Instead, what you need to do is you need to think about what it means when you square something. 2 squared, 4 squared. Okay? What is 2 squared? 2 squared is 4. That's the same thing as 2 times itself, or 2 times 2. 4 squared is 16, but that's the same thing as 4 times 4, or 4 times itself. So if it works that way for 2 and for 4 being squared, then we're going to think about it in the same mindset for x plus 1. I'm going to expand that piece right here, and I'm going to rewrite it in a way that we can actually use it. Okay, so instead of keeping that squared, I'm going to rewrite x plus 1 squared as x plus 1 times itself, times x plus 1. Everything else stays the same. The negative stays out front. plus x plus 1 plus 1. All of that has to remain. So everything that was original to the function that has to remain, I kept in red. I rewrote x plus 1 squared in gray because that's what we're going to be dealing with first. Okay. So now that we have kind of expanded that and we've rewritten it, a lot of red flags or a lot of aha moments should be going off in most of your brains because that should look very familiar. A lot of you may remember the FOIL method, or you may remember factoring, multiplying binomials. We're about to get into that in the next couple of sections, and we're starting right here with this example. To multiply x plus 1 times x plus 1, you are going to have to use the FOIL method, or whatever catchphrase that your teacher might have taught you. Whatever that might be, it ends up basically you're multiplying every single piece to something. Okay? And so that's what we're going to do. We're going to take this first term and multiply it by this first term. So x times x is x squared. I'm going to take this first term and this last term and multiply them together. So x times 1 is just positive 1x. Okay, so now that I've used everything, or x has been multiplied to everything in that second group, I'm going to move to the 1 in the front group. I'm going to multiply 1 by everything in that back group. So 1 times x. If you're using the FOIL method, those are the two inner values that are being multiplied together. 1 times x is positive 1x. And then 1 times 1 is a positive 1. That is the proper and the correct way to square x plus 1. Okay? You cannot distribute those exponents. That is a no-no. It will not work. You will mess up your entire problem by trying to distribute that. You're going to have to multiply all of those terms together using the FOIL method or whatever catchphrase your teachers might have taught you in the past. Okay? Now, once we have done that, remember, everything else stays. Everything from the original function has to stay with this. So negative times all that has to stay, plus the x plus 1 in the back. Okay. Now, keep in mind we are doing the order of operations. So PEMDAS, or the order of operations, states the first thing you need to take care of are your parentheses and your exponents. Well, we have done that, okay? Or we've at least done a portion of that. Now we are seeing that there's a negative outside of these parentheses. We've got to take care of that as well. So now we've got to distribute those negatives, or that one negative, inside everything in those parentheses. So negative times x squared, negative times x, a negative times x, a negative times 1. Some people might have simplified what's in these parentheses first and then distributed the negative. That is totally fine. That is what I'm going to do in the future, but I'm just wanting to walk you through those order of operations step by step right now. When I distribute that negative sign, or that negative 1, I'll get negative x squared minus x minus x minus 1. And then everything else from the original problem stays. Order of operations says take care of your parentheses and your exponents first, then take care of multiplication and division. Well, we don't have any multiplication and division. Then it says take care of your addition and subtraction. And so that is our final step in this problem. So when x is really x plus 1, when we're evaluating this function at x plus 1, we will end up with negative x squared minus x plus 0. And we don't have to write the 0 because it's 0. It holds no value. Okay? And so that is our final answer when we are evaluating this function at x plus 1. I have a feeling that a lot of you are going to have questions about that problem, so put a star by it, send me an email or a mind specifying what problem you have a question about, and or let me know that you have that question and what time you will be joining in on office hours. So all of that work, and we only completed part A. We have evaluated the function at each of those independent values, or x values. Part B says to graph this function. So pause this video and see what you can do about graphing this function. Alright, so to graph this function, I drew my x-axis and my y-axis. I can label those for you if you need it. My x-axis is the horizontal axis and my y-axis is the vertical axis. And then I went and graphed my points, positive 2, negative 1. Positive 2, negative 1 is here in blue. 0 on my x-axis, 1 for the y-axis is here in green. And then negative 1, so go negative 1 on the x-axis and then down 1 or 2 negative 1 on the y-axis, and here we are in orange. Now, if you try to graph x plus 1, good luck, because you don't know what the value of x is, so you can't possibly graph x plus 1 comma negative x squared minus x as a coordinate point. So you should not have a point reflecting that coordinate on your graph, because you have no idea what that actually looks like as a graph. So we won't have that one on. This is all we have right now. So to me, that doesn't give me a very clear picture of the graph. I want a very clear picture, because the directions say graph the function. It does not say sketch. It says graph, which means you've got to have a very clear picture or a very clear exact graph of this function. And so anytime you get in this situation where you're not really sure how to draw this graph, it would be a good idea to do a table of values for yourself, meaning plug in some x values and see what y values you get, aka evaluate the function for a few more values. You typically would evaluate with x values of negative 1, 0, and 1. Well, we've already evaluated at negative 1 and 0. We have not evaluated at positive 1. And so take your calculators or write it down on a piece of paper and evaluate this function at positive 1 and see what you get. 1 squared is 1, times a negative is negative 1, plus 1 is 0, plus another 1 is 1. And so I have another point that I can put on this graph right there in gray. Okay. So I've got a pretty good idea of what this graph looks like now. I'm going to go ahead and graph it. I'm going to go ahead and connect my values. I know that it tops out somewhere up there. And I'm going to connect all my points. And so I've got this parabola, or this upside down U shape. We should, based on looking at this function, we should remember that this is a quadratic function or a parabola, because it's got a power of 2. And so it's always going to be in some kind of U shape. Okay? If you don't remember that, don't worry, we're going to get into that in this chapter. So just hold on, we'll get there. But also remember that you've got graphing calculators. So when you get to a question that says part B, graph the function, all you really have to do is type this equation or this function into your calculator, graph it, and then copy over the points onto your paper. So please use those tools well, and utilize those graphing calculators since you can use them. Part C says state the domain and range. Well, the domain is the set of x values. So look at this graph. Where do all of the x values exist on this graph? Meaning, is there a place where I do not have an x value? Keep in mind, here's my x-axis, and it keeps going to negative infinity, which is right here on the left, and it keeps going to positive infinity. Does my graph do that as well? Does my graph keep extending out to negative infinity, meaning as it goes, does it keep going to negative infinity x values? And the answer is yes, it does. My domain, the set of x values that this graph covers, well, it doesn't ever stop for the x values. So it would be negative infinity, right? And then look over here on the right side. Does it ever stop? Or does the graph keep going forever and ever? Okay, and the answer is it keeps going towards positive infinity. It will have a never-ending set of x values. And so my domain is all real numbers, everything. It never stops. Okay. The range is the set of y values. So look at the y-axis, the vertical axis. Does my graph keep going forever and ever up? Does my graph keep going forever and ever down? Start with the smallest value first. Does my graph in red keep going forever and ever down? Okay. And the answer is yes, it does. So the range is negative infinity, meaning it has a negative, it never stops decreasing. So my y values will always be decreasing. Okay. But then as I look from down to up, do my y values always increase? Or do they keep going towards positive infinity? And the answer is no. Okay. They do not keep going. They stop. This is its highest y value right here. Okay. And we'll get into this in much more detail later on in this class. But what we will eventually be able to do is be able to look on our graphing calculators and say, okay, if this is the highest point on my graph, what's that y value? Okay. We're not going to cover that today, so I'll just go ahead and tell you that that highest y value is 1 1/4 or 1.25. And we'll talk about brackets later on. Don't panic. Okay. I'm not concerned right now with you understanding this specific answer. What I do want you to remember and what I do want you to have learned at this point is what we discussed in our last lesson. The domain is the set of all the x values that a function has, and the range is the set of y values, all the y values that a function has. Okay. And so being able to look at a graph and be able to point out, okay, here's all the y values, here's all the x values. That's what I want you to be able to do as far as domain and range are concerned for now. All right, folks, we have reached the end of our lesson video for today. I've got a couple of examples up here on the screen for you. And so here's what I want you to do. I want you to complete these 6 evaluations of functions. And if you have any questions, then these are the ones that we will walk through either over email or the Remind app, or a better avenue would be during office hours. So go ahead and pause this video and work through these. You will also notice I will attach the solutions for these 6 evaluations with work shown in Wolfden with this lesson video. So when you are looking at Wolfden and you're looking at this lesson video as a coursework assignment, I will include the solutions to these 6 as an attachment to that assignment so that you'll be able to preview them and you can see, oh yeah, I got these, or maybe not, maybe I don't quite have these. Okay. So pause the video, check these out, email a friend, or use your graphing calculators. And then if you have any questions, you're not quite sure about one or several of them, please feel free to reach out either by email or the Remind app, or to let me know when you plan on joining Zoom office hours. Have a good one, and I will check in with you soon.